Hello, let us look at number 3 from year 2009, Form B. Alright, so once again, I want you to look at the question and I'll highlight a few things here together. Alright, so first it's a continuous function in a closed interval from -4 to 6, and this time this is a graph of f that's given, and we realize that it's tangent to x-axis when x equals 3 right here. And then this section is twice this differentiable, where f double prime is equal to f double prime is positive here. All right, so let us look at part A first. Now, is f differentiable at x equals 0? Of course, you can see that it's not by the cusp, but they want us to use the definition of the derivative. According to the definition of derivative here, f prime of 0, for example, has to be in this particular way, where limit of the function as 0 plus h, and then minus f of 0 over h as h approaches 0 from the positive. That means we are looking from the right side. We realize that that has to be in fact equal to the limit of f of x plus h minus f of x f of 0 over h as h approaches 0 from the left side. We realize that this portion's slope happened to be 4 and then 3, so we get to realize that the first one, since this one is not equal to each other, where this one is negative while this one is positive, therefore f prime of 0 do not exist. Okay. Now, let's look at part B. For how many values of A is the average rate? Average rate, we're talking about the equation of the secant, slope of the secant line, where the slope is equal to 0. That means we are looking at here f of 6 minus f of A over 6 minus A has to be equal to 0. Slope of the secant line. Now then, in this case, since y equals 1, how many value would you have f of A also equal to 1? If you simply draw a horizontal line, you'll realize that we will have 1, 2, 2 values that would have satisfied this condition. So therefore, there are 2 values for A by, as you can see, intersection with y equals 1. Alright, let's look at part C. Is there a value A for which mean value theorem? Now, when you look into mean value theorem, we realize that it has to be continuous and differentiable, where it guarantees C value here, where f prime of C is equal to 1/3. Now, then in this case, in order for us to see that happening, we have to realize that f of 6 minus f of A over 6 minus A already has to be equal to 1/3, which is equal to f prime of C, also could quite possibly be equal to 1/3. Now, since this one is already 1, the fact that to have the slope of 1/3, change of y has to be equal to 1. In fact, that happens at when x equals 3. So when a is equal to 3, mean value theorem is satisfied. And we have to also notice that it was twice differentiable, so therefore we can assume that this is differentiable function from 3 to 6. Because f of x is differentiable over x goes from 3 to 6. Okay, let's go for part D. A function g is defined in this way. On what interval contained from -4 to 6 is there g concave up? Now, that means if g is concave up, that means f all of a sudden became the derivative. G is concave up when g prime is increasing. Now, but g prime is basically f of x, or f of, I guess, yes, f of x. So therefore, this implies that f is increasing. We get to realize that f is increasing in two locations, from -4 to 0 and 3 to 6. So -4 to 0 or 3 to 6, g is concave up. Alright, that's it. I'll see you later.